Okay, so probably we can start now. Okay, good morning, good afternoon, everyone, or good very early morning for some of you. My name is Li Chen. I'm the Markforged Application Engineer Station in Singapore, and welcome you for joining another series webinar from Markforged, the top application series webinar. And today we are going to talk about the 3D printing in sustainable supply and where the sustainability matters. So it's mainly talk about like green energy and how we can help as from additive manufacturing point of view. So our presenter will be myself and also Abbas from Central Innovation, who is a field engineer, and they will introduce something about how SolidWorks will help in from software point of view to help in green energy industry. All right, so this is my agenda. So first portion we'll talk about like cost versus green. Is that really opposite? And we see a lot of engagement or encouragement from government saying that everyone need to go for green. And once you go for green, actually you see some material actually cost very high. And then are they really implementing green will really give you like a cost raising, or it can give you a cost reduction? So is that like, are they aligned or they are opposite? And also the second portion I will mention about some case sharing from Markforged, that how related to those green energy or sustainability, and just give you some reference so that probably you can relate to your operation. And the lastly is why you need to choose Markforged as the way to have this simplicity of manufacturing, because we have Digital Forge and the whole Eiger solution, and I'll introduce that at the last portion. All right, so first of all, the trend. For demand driven, we see in the supply chain, actually everyone require faster. If you are in manufacturing, you're definitely in one of the element or one of the part of this supply chain, and you'll be chasing by your customer, and you are also chasing your supplier. So everyone actually require or by demand they request a faster turnover or faster delivery from your supplier, and give even faster delivery to your customer. So what we see is in current manufacturing supply chain, there's a rapidly changing preference. The consumer demands for immediacy, necessity, last mile supply chain, and also niche business can only grow through more offering plus customization. And a pandemic driving new products requirement and unpredictable demand. Second thing is the violent labor condition. A lot of skilled labor, actually, they have no succession planning. And for example, like a CNC machinist, it's harder and harder to find like a well-known or even like a young person willing to join the CNC machinist queue. And also incoming next generation workforce with different expectation built on a different learning foundation. And also pandemic introducing a new labor and working constraint that although you maybe have people, but it is not allowed to work full capacity because of a pandemic. And then lastly is a supply chain constraint. Instability of OEM part availability, that is due to also lack of the labor, and also reliance on the third-party supplier and the single point of failure choke point. So if let's say suddenly there's one supplier is not able to perform, then it's very the whole supply chain is very fragile. You don't have a plan B to recover that. And recently, pandemic has uncovered the kicks in the supply chain and the need for more adaptable manufacturing process. And from another side of this supply chain, some people, or especially government, looking for some policies or politics driven behavior is they encourage people to act green. Reason for being there is because first thing, global warming. We have hear this and listen this from government or from maybe your organization a lot, that the carbon pollution is very high and the sea level is raising and raising. A second thing is the WTO actually launched a series activities to face the challenge on global warming. Uh, and then also the Intergovernmental Panel on the Climate Change has been identified a range of mitigation and adaptation technologies that can assist in challenge of climate change and deal with waste. So sometimes you will see a lot of waste in the current supply chain. And one of the key example is everyone have experience with e-commerce, right? So every time you receive the goods as well as the packaging, and all of those packaging actually being thrown away or being unwell identified, then in the end they probably will become like a pollution for our environment. And also for especially in manufacturing supply chain, maybe sometimes we were dealing with chemical fluid or components, then those disposal for chemical stuff will be also uh, a certain cost for your whole supply chain. And it could be expensive because there's some business is only dealing with how to dispose chemical and they really earn a lot, right? And the regulation on disposal is actually raising. I have a higher and more and more restricted policies on the regulation for disposal things. And even right now in developing countries like ASEAN, like Philippines or Vietnam, the standard of disposal actually is raising and raising. And the lastly is additional supply chain constraint, additional supply chain for disposal. You definitely have to create one if you have certain chemical or some material that is not considered as general waste. You have to add additional supply chain and money and the labor on that, and comply the government rules for green energy. And then sometimes internally we'll have a team to tell you you need to keep focusing on 5S or lean to a lot in sometime in larger organization to drive the new, more complex behaviors. So it leads to a question that, well, acting green seems like very expensive, and also supply chain asks you to be faster. So both of them actually is it ask you to spend more money on that? So that is a question that we need to address, and we need to figure out that how maybe a new technology or a way of a new manufacturing can help. So I want to explain a little bit about background that how carbon pollution, so-called carbon pollution, and the global warming do, and what manufacturing works contributes on that. So imagine this is in the very ancient time, the agriculture time, the carbon cycle. You have your tools, like let's say this ox or some tooling or some animal for helping the farmers to do the farming and create the business. And also at the same time, actually they will consume the oxygen and omit the carbon dioxide. At the same time, actually, what surrounding them, the environment, they have trees, the grass, it will absorb the carbon and it will exchange the carbon dioxide then back to oxygen, and then it gives a complete cycle that actually the level of absorption from the plants and the level of emission from the animals, it gives like a more roughly a balance on that. And then later industrial revolution for 1.0, 2.0, 3.0, and now 4.0, right? Now slowly we have things like distribution center, manufacturing center, factories, logistics, and all these things actually it kind of unbalance this carbon cycle, meaning that the factory is not consuming oxygen and is emit the carbon dioxide, but it's like a purely in a way like a polluting or emitting some other additional carbon dioxide, or even more hazard gas to the environment, which make the carbon level higher than what we expected in before. And the consequences of the climate change is the melting ice cap, raising the sea level, the coastal flooding. We have less habitable land, extinction of species, and we have less biodiversity. And to another extreme on the weather pattern, extreme droughts, decrease the crop yield, higher storm frequency, and that you have loss of life and properties, and average temperature change, the potentially harmful for species. And the climate change is a threat multiplier. So the threats for our way life, the global food supply is at a race, then people may be starving, and also decreasing in habitable land, climate refugees. What action can we take? Purely from this carbon pollution point of view or cycle point of view, we need to make a choice that reduce our carbon footprint by ourselves and also by our behavior. So the personal choice is you can try to fly less and switch to electric vehicle and reduce the energy using. Also recycle or compost and eat less meat. There's like a personal level, but here actually we're talking about more about conventional level. So in the conventional supply chain, actually it incurs like even larger carbon footprints comparing with like every personal carbon footprints. So imagine just do a simple estimation. On the manufacturing itself, it will omit like 1.5 ton. Then on distribution is another 1.2, and then 10 ton on the flying, and the 1.3 ton on the land transportation, and another 14 tons on point of need, like the retailers. So imagine that what if we can eliminate the whole supply chain, which adding together like a 14 tons of carbon dioxide pollution or emission, converted into a smaller but more portable and easy to use solution, which is 3D printing. That is only talking about gas emission like 0.8 ton for the same volume of the parts, but there is like a way lesser carbon dioxide emission. And at the same time, additive manufacturing can give a greater factory efficiency. You have less waste. Only print what you need. You don't have to like upstock, or you don't have to adding additional infrastructure for transportation or for producing that. Basically, just one hardware and one material, and use software to control it. And one person will do. And also reduce the energy consumption. Our machines, you can use the normal power, not necessary to have like three-phase or 380 voltage, the high power to run this machine, because machine is actually like a desktop grade or even like industrial grade, is not that big, right? And more space efficiency. We literally remove this geographic difficulty from the actual movement to moving by digital by cloud. So you actually send the part digitally from laptop to another laptop, regardless that what location it is. As long as that location have a printer, you can print the part exactly the same as what the starting point want the endpoint to do, and you can do that in like few pieces or many pieces, whatever you want, as long as you have the infrastructure of having the printer basically in the local region. So and also talk about supply chain. Everyone should see this news like pretty hilarious that we have one team of engineers. We have this one equipment to try to solve this Suez Canal stuck thing, and it's really hard working for a very long time. And imagine that if your goods is on this ship and it can't be deliver on time, and your customer, you're potentially losing your customer, and your stuff, your goods on the ship maybe got, I'm not sure what kind of parts it could be, but maybe some of the part will get expired, and no matter what consequences, all of them are negative consequences. And that is the risk on the current supply chain or current logistic concept. And also another case is 10 years back, there's a volcano explosion in Iceland, and it caused the ash cloud all surrounding the North Europe, and all of those flights for air delivery for logistic having stopped. And this is also potential risk for not just by ship or by landing transport, but also by air. You may see sometime have this kind of disruption. And although it may be not as long time as like COVID pandemic, but this will also like contributes a lot of like potential bad consequences. So again, back to the question. So is green constraint to the cost saving? So not really. So, but how are we going to do that? Simple question is we need to find another technology or another solution to eliminate the current supply chain or current value chain that we have, from raw material to manufacturer to material distributor to vendor and out to end user. It's too complicated, and it's have risks everywhere, and they have pollution everywhere. So one of the way is maybe just change partially of this supply chain or the value chain is by using more renewable or regenerative energy, like solar energy, wind energy, water energy, tide energy, and geothermal energies. Or the other way is to find some other possibility to have less pollution, like new energies. Example, electric cars. Or in Japan, we have the maglev train. So both of them actually don't use petrol, which give less pollution as well. So my example, which leads to the next portion, my example will talk about like how, besides on the whole concept replacing the supply chain, in regards that just now those portion like green new energy and the regenerative energy. What are the footprints that Markforged have been done for our customer? So this is the first one. It's in the clean energy. Company is called Mintai Industrial. It's in Taiwan, and this company is actually, although it's not big, only like 50 to 100 people, but they are actually the top 5 spring manufacturing all over the world. And one of their biggest portion on supplying their spring is for wind turbine system. So this is related to wind energy. So first thing, when they look at 3D printing, the reason they're looking at that is because first thing, the COVID actually make the supply chain get interrupted. Before that, this is because this is a very niche industry. So people only have few famous brands, and luckily Mintai is one of them. So all over the world, people come for this Taiwan supplier to get this spring be manufactured and sent to them. And the big players for the wind turbines are always purchased from them. But because of the COVID hits, like European or South Africa customer, they try to find the other way around to cut this supply chain from Taiwan to themselves locally. But rather than just maybe try to find some other solution in-house or in region, in this case, some niche industry like this wind turbine industry, the overseas supplier get competition with the local supplier, some local unknown supplier. So they feel get interrupted. And also at the same time, they can't get enough supply from their vendor. And the demand is still very high, but the supply is very low. And last year, they decided to purchase the X5 industrial printer from Markforged. And the Markforged printer is able to give them the capability to produce high critical parts at the point when they need it. And also it test proof that this solution can be used in wind power spring as an end-use solution. So you can see on the right side, the bottom right picture is actually a casing is made by Markforged with a Markforged solution, which is onyx plus carbon fiber. And inside it installed the spring. You may know that actually when they start to rotate, the spring actually have a very high pressure internally, the strain pressure internally. So in order to keep that, the material itself need to be strong enough to hold this internal pressure. That and also that's give the reason that they have to choose Markforged, because one of the fastest solution is 3D printing and one of the strongest solution is Markforged. So you can see actually this part is being located at here, and outside is totally printed, and the whole solution here is actually in the picture here that will be located into behind this wind energy for the final use. So the whole value for exploring this additive manufacturing solution is they found the problem because of the COVID, and they try to solve the problem. So they tuned down to the MRO parts, especially for the more urgency part is on the MRO. Then they realized the value of using additive manufacturing is one thing. One key thing for them is they can do the digital parts inventory. They don't have to stock whatever MOQs for this casing, and also it can optimize the performance. Now they have more freedom on using. Lastly, they will have optimizing the performance. They have more freedom on designing this part and also deliver the part new design to the customer in a very, very fast manner comparing with previous outsource the sample, get back, change the design, then outsource again, then do the final product, then pass to customer. Now everything can be done just in the one lab in their office. Cool. Second case is on clean energy as well. Is the electric cars company. It's one of the famous brand, but I can't mention the name. And the new product development in the company actually have a very huge demand because it's a new brand but very famous. So they're always being expected to creating launch new model over and over the year, and the demand, the request on launching this actually become faster and faster. So so the new product development team decide to require RP tooling, and also at the same time actually this tool is supposed to give some tooling manufacturing support at the same time, because of they don't want to fully rely on the current supply chain, and especially establishing the new factory site. So when the new factory is establishing, a lot of tools, a lot of parts need to be printed and be used in the factory. So again, additive manufacturing is being considered into this one of the potential solution. And also end up they choose Markforged. And now they have Mark II in China, and also have multiple Mark II and X7s in North America. So starting what they see is from parts to parts comparison. So one of the manufacturing tool can help them to save like $400 if they use additive manufacturing. And then, but once they have their machine, they realize the usage or the capacity for one printer probably is not going to be enough, because more and more departments see the value of faster printing, so that they can print a faster, they can print the part in a faster manner, and they can be have the advantage in the market on deliver the parts earlier than other competitor. And the year over year, they need yearly comparison, the savings by using this additive manufacturing solution from Markforged. They have 10% year over year expansion into the new verticals. So, and lastly, this is another customer from Australia who is really apply this digital factory on site on helping themselves to print some tools that they need. So enjoy the video here.
Hi, my name is Ash Weston. Welcome to Mech 3D. We're at our new premises in Canning Vale. We're a mechanical design, prototype and print service, as well as the first Markforged print farm in Australia. the reason you use like one of our Markforged printers for your product or your design or your prototype would be just the end usability. Like it's the parts are very strong, the quality is exceptional. They're just, you can't get that sort of strength out of traditional printing methods. So with Markforged, the carbon fibre nylon mixed, which is called Onyx, it's just a great material all around. Then we can also reinforce that with fiberglass and carbon fibre, Kevlar, and it just adds so much strength to the parts. You just can't really beat it. There's nothing else that comes close. So we're just going to take a look at some of the stuff that we're actually making with the Markforged printers. These are some brackets that we're doing for WestTrack. They bolt up some radios, and the reason we needed to utilise the Markforged technology is because the Onyx itself is a lot stronger than ABS. This project we were initially going to use ABS, but with temperature properties and strength properties, we just didn't want to take the chance, and to get this into mining, we wanted to put our best foot forward with technology that we knew worked. So the Onyx was our choice for this, and this is the result of what we've designed and printed. They're currently being used on a site in WA, and they're going well. The proof of concepts are pretty much complete, and yeah, there's a lot more work to do. We also have some batteries that we're doing for a mining company. These are printed in two pieces. The original prototypes were done in PLA, and then when we had the design right, we actually printed these in carbon fibre. We're printing these solid just to get that strength and rigidity in the part, so you can see that they're quite strong. These bits bolt together, so this is an assembly, and they house the batteries, which we then weld together. Another bracket we've done here is this is actually for a ignition coil mount in a car. So this is sitting in an engine bay, which is bolted to an intake manifold. We've got nuts that we can insert into the backs and actually embed parts, off-the-shelf parts, into printed parts. So yeah, we're doing a bit of testing with these and going to see how well these hold up in engine bays, and I don't think we're going to have any issues with vibration and that sort of thing, as the Onyx, it's one of its great properties is it's not susceptible to vibration. Using these Markforged printers we have here behind us, we don't just prototype only, like we actually production print for like large volumes. For instance, these here, we have a couple of hundred of these to print. There's about 3,500 hours of printing in it. So we've actually taken this technology and used it for not so much mass production, but large volumes. These batteries, we have 125 of these to print in the first order, which is about 700, 800 hours of printing in these. So as you can see, we're not just printing one-offs for prototyping. We can actually put your product into manufacturing and actually supply large volumes. So this kind of just proves and backs up the end-use part kind of idea that Markforged has behind them. It's not just used for prototyping. The reason I went with SF was literally because what you guys could offer and to build that relationship and work together. You guys had the tech support more than the others, and that you guys were actually in the design game as such, whereas others aren't. It was because you guys are in the design world, like you guys are mechanically designing stuff, and just had a lot more to offer. It was more like, looking at going forward that you guys had a lot more to offer, whereas the others, it was going to be by the printers and that was the end of it. And not, because I see that as like, you guys you're not just selling printers, you're offering a service. Thanks to SF Design for putting this video together and taking the time to come out here. Thanks for supplying the printers. You guys have been great to work with, and looking forward to the future.
Right. So I hope this example is going to make you have an impression that these 4 printers behind him is like a manufacturing engine. So they can do the manufacturing on site behind settings. It's very simple, like few racks, then the machine setup, then you can start the print already. Versus like some factory settings, you need to do a fully preparation, and you need to have certain a space for holding those things. And also it's just like a one-stop solution. You print it and you have that and you just deliver it. And also there's no much waste as well. And what really impressed is, I would say is another point is that all the parts can be really used lively as an end-use product. It's no longer a rapid prototyping machine for people's concept of how additive manufacturing is. Right. So lastly, I'm going to say that some details about products on why Markforged is the choice. Right. So we are offering a platform called Digital Forge. So this Digital Forge is supposed to be is everywhere, and our Digital Forge is a combination of the enterprise software, industrial 3D printers, and also industrial materials. All 3 elements are essential, and they are equivalent essential for this Digital Forge. We're using the software to combine the material and the printer in order to give this constant output. So, and all this is all come from Markforged ourselves. So, meaning to say that if I have a part I want to print on my printer in Singapore, and you have another part, you have the same part, and you have the same set of printers, Digital Forge platform in Australia, you should have the same output as what I have right now here, and also the exactly same output like what we have in headquarters in Boston. And this is the lineup of our printers, industrial printers. So we have the X7 composite printer, and also the Metal X system, which includes the Metal X, the wash station, and also the Singer tool. On the material wise, this is all the available existing material for our current platform. We have Onyx, which is the chopped carbon fiber with PA6 composite material. Onyx FR stands for fire retardant, and nylon white material, and Onyx ESD, electrostatic dissipative material, for some electronics industry customer to use. And by having that, you can do even more is the reinforcement, which is our continuous fiber family. We have the carbon fiber, Kevlar, HSHT fiberglass, and the normal fiberglass. This is all about composite. And when we reach to metal, we have 6 material at this moment: 17-4 stainless steel, Inconel 625, H13, D2, A2 steel, and pure copper. And they all serve for different application conditions. And moreover, the more important thing is to eliminate the current supply chain, or not eliminate, like compensate the current supply chain, also help the global manufacturing become less waste. The key is the Markforged solution is the cloud architecture. So imagine that you have like in a very big organization, there is a global part manager. And previously what they do, they need to have the parts being stored maybe in paper, in drawing, or in the actual part in stock in their factories. and then he need to use a ERP system to manually input or to update all the parts updates and the part status. And then those inventories, once one site need one part, then you need to ship it. The other side need another part, you need to ship it again. So it's a very tedious procedure. But currently here you see is like cloud architecture. Is this the same guy, the global parts manager? He used his laptop to manage all the parts. No more space, no more MOQ, and no more logistic. And what he do is instantly trigger the remote print from his laptop, which is software, and he can manage to manipulate all the printers on different sites. And he can send the parts to the certain printers, and that printer will automatically print. So when the person requests a part from this global part manager, the only information he will get is you will receive the part in your printer, in your own printer, by 2 days. That is only depends on the lead time, is only depends on the printing time, and all the files or all the samples, all the parts being stored digitally into the cloud-based software. And he can retrieve and do the modification and save multiple versions of one STL or one print one design. There's no problem at all. And you may ask that there's also a common question that people ask me, that when it goes to cloud, is it really safe or secure? So the Markforged solution actually is by now is the only solution or the only organization being ISO 27001 certified, which means that this ISO certification is a cybersecurity certification. So which means that it is a proven certification by ISO standard, and a lot of like a big enterprise have been used our cloud technology already. And moreover, it is an on-time improvement, meaning that if, let's say right now, for certain printer have problem, you'll receive the error, and if anything need to do from the printer, it can be done. Anything need to do from the software, it can be done. And also, Markforged will keep improving and adding more features by the time goes, launching more materials or launching more printing features. And as long as you're using cloud-based software, the software will auto update, and also it will help the printer being updated firmware automatically. So here is the short video about our IGA interface, how it looks like. So you have few interfaces for allocating use fiber as an example, like inserting the file and allocating the fiber you want, then send the job from the software to the machine. Yeah, of course, you can print like multiple parts at one time in one tray. Then click the print, and the printer will go. And also another feature that we just launched in March, which is blacksmith. So this is a software feature. It's a really AI-powered adaptive manufacturing features. So how does it work? There you go. So it's basically a scanning in process during manufacturing equipment for our X7 with blacksmith. So I assume that everyone should know that 3D printing is printing layer by layer. So how this is going to work is every time you finish the print, that layer will be scanned to make sure the quality. And once you finish the print, at the same time, you'll receive a report about the quality check, which is what we always say like QC check. So it is like an instant. It's like the same time auto feedback once you finish the part, give you a report already. And then what going to improve is the software itself are going to read that feedback, read that scan report, and then do the improvement by itself. So the designer design the part. If there's any offset, the printer will help the designer to compensate. And what it compensate is actually do the comparison on the actual design versus the actual print. And if there's any offset, then they will do the changing on the tool pathing or to the movement or etc. And end up you will have like a keep improving machine with the experience of gaining from those QC report from blacksmith. So in the previous time, there's no such manufacturing equipment is able to do that. Nowadays, this equipment is coming out, which is the X7 with blacksmith. So more, I believe that definitely you'll have more doubts or more questions about this machine, how exactly it works. So please reach out to us after this webinar, then we will arrange the regional team to give you a demonstration on this blacksmith thing. Also, another thing is for talking about manufacturing in supply chain, how to try to make the distance be shorter and shorter. One of the things is why not we are trying to figure out a way to make the manufacturing be portable, meaning that during the moving from one place to another, it still can have the same capability or fabricating the part. And here we are introducing the X7 Field Edition. So it's actually a X7, but in a very simple way of installing it. So it's supposed to be in the below the Pelican box, but by opening it and making sure it can operate and the print is it only costs you like 2 to 3 minutes by 2 person, and it can be done by printing inside inside even a car, as long as you have enough space and there's no much vibration. So you can print. Imagine like a real road show for manufacturing is using the equipment in the road and do the live fabrication, which this machine is a perfect example. It is able to do that, and also it can help you to eliminate the lead time in a way for the landing transport. So yeah, here's a few steps of how a few things that are including here. A Pelican box, inside you have the printers, and another layer you have all the tools required to maintain or installing the printer, and also the materials required to print. Everything can be very compact being installed inside the Pelican box. Cool. So that's pretty much all we have about supply chain. And the last slide is just for showing that manufacturing is very broad, and for all the different industries like aerospace, automotive, space, defense, medical, and automation, we all have different kind of outreach, and people start to, it's not a news, people already start to adopt this additive manufacturing for their toolings or rapid prototype or even a used part to try to acting green, at the same time try to reduce costs and also make the supply chain be more tough, not as fragile as just one chain of the whole supply chain. So that's all I have. So I will pass to Abbas on introducing how SolidWorks can help us on the green strategy. Abbas, there you go.
Thank you, Lichin. I'll just share my screen.
So a reminder for all the audience that you can put your Q&A in the Q&A bar that are underneath the screen, and we will do the answering after all the sharing.
All right. I hope everyone can see my screen now.
Yes, we can see it.
All right. Thank you. All right. So I'll quickly introduce myself. My name is Abbas Madraswala. I'm working as a field engineer at Central Innovation from past 2 years. And I've been working with SolidWorks from more than 12 years. So in today's presentation, I am going to talk about SolidWorks sustainability to design green products and to check how it's how our design is impacting our environment. So let me just quickly introduce Central Innovation. So Central Innovation is a technology partner for manufacturing industries across ANZ. So we have been in this business for over 30 years, and we have around more than 10,000 customers across ANZ. So we provide different software solutions. You can see the names of the software in the slide. The important one is the SolidWorks CAD. So today in this presentation, I'm going to use SolidWorks Sustainability to demonstrate to design green products. Then we have a hardware where we purpose-built systems based on application like CAD modeling, simulation, or rendering. In systems, we control like managing your documents and to even connect or integrate your mechanical CAD data with your ERP or CRM systems. In people, we provide training and we also have a recruitment division that helps you to shortlist people based on the skills what you require. All right, so this slide shows the innovation platform. So where these products or these tools are being categorized. So for example, in design, we have tools for mechanical, electrical, woodworking. For validating our design, we provide structural analysis, flow simulation, plastics. Then for again managing your data, we have PDM solutions. And again, for integrating, we have a data suite. Then for communicating your design with your customers or even between different departments, these are different set of tools. And finally, to configure or automate your design, there's a DriveWorks tool which can be used. So to just recap, from design to production, we provide different set of tools to different stakeholders. We provide different systems for managing your data and also for integrating your data with your ERP, MRP, or CRM systems. And we provide services that includes training on softwares, provide technical support, implementation, and consultation. If you have any questions in this slide, in the end of my presentation, I will leave email, so you can just write me an email, or if you have any further questions regarding this. So let's start with SolidWorks sustainability. So this image, what you see over here is what SolidWorks sustainability uses for life cycle assessment. So Lee Chen already explained like how the carbon footprints are emitted especially during the manufacturing stage over here. So SolidWorks sustainability considers it from raw material extraction to its end of life. So there are different stages in between them as well, like material processing, then part manufacturing. So in part manufacturing, we saw that 3D printing helps you to reduce your carbon footprint and design green products. After that, the parts, once it's manufactured, it's assembled, and then it's used by the end user. And finally, after the use, there's an end of life for that product. So in every stage, there is a transportation, which is also included in this life cycle assessment. So now what are these are the 4 results what we get as an output in sort of sustainability, which affects or which helps you to check how our design is impacting our environment. So first is the carbon footprint. So that's the emission, which is carbon dioxide or equivalent like carbon dioxide and methane. Then total energy, which is the energy consumed. So these are all form of non-renewable energy, which is consumed over the total life cycle of your product. Then air acidification, like the acid emissions such as sulfur dioxide or nitrous oxide, so which eventually leads to acid rain. And water eutrophication, so this is a contamination of water ecosystems by release of industrial waste and fertilizers, which causes algae bloom and which eventually leads to the death of plants and animals. So let us take an example now and look in SolidWorks sustainability to check these results. So we'll take an example of this humidifier assembly. So SolidWorks sustainability can be activated from the SolidWorks application using the sustainability tool. And once we have enabled this in this property manager, you will see the sustainability property manager where we can define this process. So first is in this property manager, you will see where this humidifier will be assembled. So we can select a region where it's going to be assembled. And we can also input like how long it will last. And after that, we can specify which is a use region, like where the product is being used. So let's say this product is going to use in Australia. So selecting Australia over here. And in each this manufacturing or assembling or in the use region, we can also specify which is the energy required in each process. So this will further take into account that quantities as well. So the transportation which we saw in that life cycle, so that we can also specify over here. So we can specify as a railways or roadways, waterways, or by airways. And last is the end of life. So here we can specify how much percentage of it will be recycled or incinerated, or it will go to landfill. So once you've specified what in this results, what you see in this bottom are the 4 parameters what we just discussed. And when you change any property, this dashboard will update accordingly. So what we'll do is we'll set this values as a baseline. So if we modify our design now, so we'll see whether this is improving or it's worsening in terms of this environmental impact. Now, this SolidWorks sustainability is integrated in SolidWorks. So I'm using this assembly visualization tool. So this helps me to find out with color, like which quantity which I've selected, it's having a highest carbon footprint. So we can add this sustainability properties in that columns as well. So there are different properties which we can add in this column. But what I'm interested over here is to check how much is the carbon footprint. So for these two components, so let me just expand this. So for this top cover and this underbase, it's having a highest carbon footprint. So if I select this top cover, so the sustainability property manager will update as well. And now you have the same properties, but now it's for this part only. So for this part, it shows what material it's using, again, where it's being manufactured, what is the manufacturing process, where it's going to use its transportation and end of life. So again, for each part, we can specify these properties as well. So now what we are interested over here is which material we should select to reduce our carbon footprint. So we'll use this find similar tool to select this. So what I'm going to do is I'm providing some conditions over here that the material which I'm selecting should be plastics. Then the density, it should be a little less dense than the current one, since it's going to be used in a hot environment. So its thermal conductivity should be less. So after providing this condition, I will click on this find similar tool. So it will list all these materials from database. So over here, I can further select this materials and filter it down to just concentrate on this material. So once I select this material over here, it will show you how it's impacting our environment. So with this material selected, the carbon footprint is reduced by 84%. For this PP copolymer, it's around 88%. And with this homopolymer, it's around 85%. So we can say that this one is reducing by 88%. So we'll accept this material now. And once we have accepted this material, that value is updated over here. And similar process, we can do it for the second component as well. So let me just select the same material over here as well. So by just changing the material, we have reduced this carbon footprint. Now, if I click anywhere in this graphics area, so it will update at assembly level. So at an assembly level, we'll come to know again how much we have improved. So from the baseline, which we have set earlier, so it's reduced by 59%. We can also generate a report as well. So by just clicking on the save as, we can generate a report. So this is just a copy of a report I've saved already. So over here it shows you your component which you are studying, its weight and where it's being used. Then also what it gives you in detail about by division, like how much carbon is emitted during material stage, manufacturing, use, transportation, and its end of life. So this report gives you in much more detail about those values. Second thing is we can also integrate it with simulation. Sorry. I'll just close this assembly visualization. So what we are going to study now is for this tank component. So now since this is a personal humidifier, so somebody can keep an object on this particular tank. So let us open this tank in its own window. So again, for this particular part, the sustainability will show me the current values over here. So again, what we'll do is we'll set this as a baseline. All right, so let me just quickly enable SolidWorks simulation. So over here, what we're going to study is we'll input a load condition. So we'll on this top face over here that will represent some object which is kept on this face over here. So let me just switch to this study now. And also there is a hydrostatic loading which is applied on the inner face of this component. So we'll quickly run this study now. So it will take a few seconds to mesh and run. So what we're interested in a factor of safety, and we want to keep factor of safety around 2. So on checking this factor of safety, it's above 2, so it's around 2.7 over here. So now from the structural point of view, it's good enough, but we want to reduce further carbon footprints. So again, what we'll do is we'll use the same tool, which is find similar. So again, over here, our material class will be plastics. And over here, we want a density, which is approximately the same. But we require a tensile strength, which is greater than the current one. So again, we'll click on this find similar, and again, it will list or show all the available materials. We'll further drill it down, and on selecting, again, it will show how it's impacting. So the first two ones are approximately 50. And for this homopolymer, it's around -34. So we'll select this copolymer again. So out of these two components, this one has a higher tensile strength. So we'll accept this one material. And what we'll do is we'll again switch back to our simulation study, and we'll quickly change our material in the simulation study tree as well. So again, from this material, we'll select this copolymer, which we changed for the sustainability, and we'll quickly run this study now.
Hey, Abbas. Sorry to interrupt, but I think we are now running out of time. So maybe you can.
This is almost completed. Yes, almost completed. So just checking this factor of safety, and we'll see that it's now safe. So finally, we saw what we see over here is that it's reduced by 50%. And if we switch back to our assembly, so it will show you overall how it has reduced our carbon footprints. So on again, it will just recalculate these parameters, and we find that it has reduced the carbon footprint by 53%. So this helps us to design our product which considers our environment, and it's very easy to understand and very effortless to apply that settings as well. If you have any further questions regarding this presentation, please feel free to write me an email, and I'll try to answer that for you. Thank you.
Thank you so much, Abbas. So we now need to pass the mic to Adam to mention something about some funding from government in Australia that if can be beneficial to the audience here.
Yeah, thank you very much. Can you guys see that one?
Yes, we can see it.
Brilliant. Okay. So I'll kick it off quickly then. Yes, my name's Adam Taylor. I'm from EY in the Government Incentives team. And today I just want to talk to you about a couple of opportunities that are available in the government funding landscape in Australia, and those ones specifically which relate to recycling and the clean energy industry. So we're looking at ways that you could align projects that you have in your pipeline with potential sources of upcoming funding. And while there are thousands of funding opportunities out there, I really just want to focus on one today, and that is the $1.3 billion Modern Manufacturing Initiative. So this pot of funding is split across 6 national manufacturing priorities, one of which is for clean energy and recycling. And within that, it's actually split up into 3 individual streams, as you can see on the screen. So the first is the collaboration stream, and this is aimed really at the bigger end of town. So it's looking at providing capital for very large research projects that support business to business and business to research collaborations. The second is translation, and this is aimed at commercializing and investment in non-R&D innovations. And the third is the integration stream. This is aimed at assisting manufacturers to integrate into local and international markets and supply chains. So for each of these national manufacturing priorities I'd mentioned, when funding is opened, a priority roadmap is released, and this identifies more clearly the vision or specific growth areas that the government's looking to fund. So the first round for translation and integration for clean energy is actually open, which means the roadmap has been released. And they've specifically highlighted 3 key areas for growth that I want to go through with you. So the first is manufactured projects that enable recycling or use recycled feedstock. And examples that you might include in this could be recyclable products or packaging, or making products from recycled plastics or electronic waste. The second area of growth is manufacturing products that use or enable clean energy. This is quite broad, include areas like hydrogen technologies, modularized renewables, microgrids, electric vehicle chargers, next generations of photovoltaics, specialized batteries, or low emission steels. And third is a bit of an overlapping area of manufacturing, such as carbon fiber or graphene or other advanced materials that are involved in the recycling and clean energy components. So the 2 areas that I want to flag to you for your consideration is first the translational stream, which is looking to back manufacturing businesses in strategic projects that will increase commercialization, embrace technology, innovation, and automation. And they're looking to fund areas that are trying to grow production and bring commercial outcomes to new or existing markets. The integration stream, on the other hand, is looking to invest in projects that will increase manufacturing businesses' participation in new local and global value chains, again, by embracing technology, innovation, and automation. So applying for any of these applications, the grants will be competitive, and your process is assessed against a merit criteria, likes of which is shown on the screen. So the first is the alignment of your program to the objectives, that's 50 points. The second is your capacity, capability, and resources to deliver your project. And the third is the impact of the grant funding on your project, and that's about 20 points. So while we're on that, the funding structure for this stream is 50% co-funded, and it's looking to offer between $1 and $20 million for projects. So just to clarify, the minimum project expenditure they're looking at is $2 million. So along that lines, what are the eligible expenditure that you could include to get up to that $2 million minimum? So first off, we have plant and equipment. This could cover things like designing, acquiring, installing, construction of plant and equipment. It can also include the likes of software, but it is limited to where the software is required to facilitate the project that you're undertaking. The second is labor, and this will cover things like your direct costs for employees, technical project management, or third parties are involved. It is worth noting that the administrative side is not actually covered within this. You can include prototypes, so that's covering the construction of a prototype to prove that it's commercially viable, or in the intellectual property protection or acquisition phases. And then there's a smattering of others, such as travel, building modifications, staff training, that kind of thing. So if the streams in the MMI don't necessarily align with your projects, or the spend might be a bit outside of your range, there are a few other options that I've just highlighted here. The first one is the Clean Energy Innovation Fund. And In this one, they're looking to invest in companies that have passed through their R&D phase, and they're looking for early funding. And this funding comes in as a case-by-case basis, and it's actually equity-based, so it's not a co-funding system. Next on is the Advanced Renewables Program, and here they're looking to fund a broader range of the development cycle. So not necessarily just post R&D, they're actually looking at technology readiness levels 4 and above, and the funding range is much broader. So they're looking between 100K and 50 million, and it's at 50% funding. This one is not actually open at the moment, but historically it shows that it should be opening at some point in 2021, so maybe worth your consideration. In addition to these, there are also funding sources looking to promote reliable, clean, and affordable energy supply in homes and businesses via what's called the Net Zero Emissions Fund, maybe worth your consideration. There's also a range of opportunities with an emphasis on job creation. So if you are looking to expand, it can be state-based. If this still doesn't fit the bill, consider leveraging non-grant sources of funding via the R&D tax offset. I do want you to be aware, though, that this is just a snapshot of funding opportunities that are open or opening in the near future. The landscape changes frequently, and aligning your projects to funding sources and the objectives is an important part of increasing the likelihood of any success you would have in a grant application. The opportunities that I've listed are Australian-based only. If you're joining the webinar and you're not based in Australia and you would like to discuss potential funding, please reach out to me on the details listed on the screen there, and I can leverage EY's global network and connect you with someone in your local area. If you do have a project that you think may align to any of these funding opportunities listed, and you would like any assistance in scoping or preparation of an application, please reach out to me. I'm more than happy to have a conversation or explore your opportunities. Thank you very much, guys.
Thank you so much, Adam. And also thank you so much, Abbas, for introducing the SolidWorks features. I actually, before you introduced, I didn't realize that you guys have these features in software. Can recognize the level of carbon for different material or different design. That's really awesome. So we are now open for questions. And before that, I just want to do a reminder for some of you may join from 11 a.m. Singapore time or Perth time. Sorry about that. We have some confusion on the time zone. That's why maybe you receive on the invitation is at 11 o'clock, not 10 o'clock. But if you do want to see the rebroadcast, we have recorded for this one. So reach out to us and we will send you the on-demand webinar rebroadcast again. So, okay, so let's head to the Q&A. So I received a few questions. I think first, maybe start from a question about SolidWorks. Abbas, the question is for you, is the material selection is most conventional plastics. So how about 3D printed plastics? Are they able to show in your analysis?
All right. So the material, what it's using is from the SolidWorks database, and the underlying technology which it's using for calculating this LCA is from PE International. So whichever the materials which are there in the SolidWorks that database, so currently that one is supported with the sustainability. If you want, I can still check for the especially for this 3D printed material, and I can get back to you again on this one.
Sure. Okay, then I'm going to answer those questions about 3D printing instead. So the first question from anonymous attendees, if you were to introduce the LCD 3D printing solution today, so unfortunately, Markforged doesn't provide any LCD 3D printing at this moment. So here we mainly talk about the FFF and CFF for composite printing, and also the ADAM, we call it atomic diffusion additive manufacturing for metal. So there's no LCD printing yet in Markforged. Okay, second question from Nick. Are you aware of any application where the material has been used in a subsea or marine environment? So the answer is definitely yes. We have some study and also case study about a case and also a study about how our material after submerging into water and what is the performance and we are happy to share with you on that. So please reach out to us. So maybe I can type my email here. Right. So for people that you want to have more answering or more files or document, you can reach out to me at this website, this email, sorry. And 1 second, let me find the Abbas email and Taylor's Adam email. Yes, so Abbas email is right here. And Adam email. Sorry, ladies and gentlemen, give me 1 sec. Yes, and this is Adam email. There you go. Okay, continue. Next question from Jordan. Are there examples of any Markforged components being used within the automotive industry? If so, what would you recommend the material selection within automotive racing components? So my personal preference and my suggestion will be carbon fiber. So carbon fiber is actually our best strength versus ratio or weight ratio material, and it gives you the superior strength at the same time is the lightest density that we have for all the continuous fiber we provide. So again, we have a case study on about racing car components. So happy to share with you offline. Okay, and Mr. Dana asked something in Bahasa, so I cannot understand that. So maybe your colleague or your friend can translate it into English, and I will answer that after that. All right. My email, Clinton asked me the email, my email, and Adam and Abbas' email are all here. So feel free to reach out to us. All right. So next question. Thanks for the presentation. Very obvious question, answer most likely about the AU grants. If you work for an Aussie brand outside the country and have a green technology that we want to exploit, where product would go global, are boundaries or for grants extended based on the credibility of the products of the projects? Obviously, it's a question for you, Adam.
Yeah, not a worry. So not to my understanding, the MMI looks to fund for onshoring manufacturing within Australia. But given that you're an Australian brand base, it might be worth taking this offline to have a bit more of an in-depth discussion to see what work is being done globally and where the brand actually sits within Australia, what's being done here. Yeah, if you could contact me on my email address, I'd be happy to have a quick phone call or something. Thanks.
Cool. Okay. Clinton is asking, does your printing replace steel parts? Is it as strong as it is accepted to replace steel part on site with your alternatives? Apologies, there's a new era for me. I'm surrounded by and work with many mine sites. So very interested to uncover opportunities. Yeah, thank you for that. At least it proved that our presentation really reached the interest and have some maybe so-called uncover opportunities for you. So to answer the question, yes, we can replace steel part, or even like our metal printing, we can print the steel parts. So the quality you can say is like we call it like relative, like a near net shape, which means like similar to the casting quality. I'm not sure, Clinton, where you base, but definitely you can reach out to me and I can link you with a local team to have the further discussion, or even like give you some benchmarking for you to do the testing, or if you have like testing equipment, then you can do the apple to apple comparison on the parts that what we produce by our steel versus your steel part, or maybe you are mentioning you are talking about using non-metal printing. There's also a chance, but we need to see the actual working scenario. But for sure, what I try to say is that there is already have a bunch of customers using that our composite to replace metal, and also use our metal to replace their current metal. Either way. All right. Okay, so Richard say we'll reach out to you. Stefan asking, do you have examples of making metal composite part for subsea industry? Yeah, as I said, we do have that. Reach out to us, and we will reply you with those documents offline. Okay, Fahan is helping Dana translate those questions in English. So the first question is, what is the impact of 3D printing technologies to the manufacturing world? So the 3D printing now, what we understand is we are trying to compensate for those scenario that probably now is not that conventional manufacturing is not that convenient to do, or you have some constraint by your current supply chain. Then nowadays you can use 3D printing to do that, and the application can be start from a few decades back. It starts from rapid prototyping, and now we are more talking about actual tooling and also end-use product, because the strength of our printing material can really reach to the end-use level. Okay, second question is, what are the advantages of 3D printing technology compared with other conventional manufacturing? So it depends on the scenario. Maybe currently you have like we can address some problems. Currently maybe you have like a few weeks or few months for lead time for getting one part. Then now you can use 3D printing to print instantly just from the printer. Then you can have the part in next day. Or by adding so many supply chains people joining, then your cost of getting this part being accumulated to a very high price. Then now you can cut off all the different tiers for getting the money from you. Then you can just print by yourself, and then also you don't have to have any MOQ, or you don't need to have any storage for like unwanted quantities of parts that cannot sell. Maybe customer only want to get one from you, but you have to order 10 from your supplier. So all those things can be eliminated. And what are the advantage of 3D printing process can be considered as green technologies. So we have less pollution, and also we try to eliminate the transportation from the value chain, and also the waste of like I said, the quantity waste, you don't have the restriction from MOQ. So all this is print on demand. So it's really like very little waste, and also your labor is not all the time need to focus on that machine, because this machine is more like 90% or 99% or fully automated machine. Cool. All right, another question comes up. Charlie is asking, are you able to print those tungsten carbide in the green states? Answer is no. We don't have the option on tungsten carbide. Don't have that superior material yet, super alloy yet. All right, we clear all the questions, and it's already extended to another 20 minutes. So any further comments you guys want to have, Abbas and Adam?
All good from my side.
No, all good, thank you.
All right, cool. So thank you so much for all the attendees joining, and apologies for the confusion on the timing. So any questions or any you want to see rebroadcast, reach out to me. And the further question about software, reach out to Abbas, and the grounding in Australia, please reach out to Adam. And we are looking forward to see you in the next series webinar. It will be talking about a new topic. It's different from this topic. So stay tuned on our advertisement in LinkedIn or in Markforged website. And looking forward to see you guys next time.
Thanks all.
Thank you, Adam.
Thanks,
See you
all.
guys. Bye.